So today we're continuing to look at some of the futures around the tech. So like yesterday, so we went through fundamentals on Monday. Yesterday, I'm sure you heard a lot of real life case studies, a lot of learnings. A lot of today is about still some of that as well, but looking at, okay, what do we need to do to master the tech in order to scale passkeys, and also like in other adjacent areas, other use cases, and in the broader context of things like identity wallets, which there'll be a panel on that at the end of the day. But with passkeys, there is this inherent need for credential manager, which is a great thing. But if you have your passkeys in a credential manager, how do you get into the credential manager? With a password? That's probably not where we want to be at. I don't know, Rue, is that where we want to be at? Well, let's let Rue Islam from Dashlane tell you where we want to be with that.
Thanks, Megan. Good morning, everyone. I hope you had a good time last night at the Passwordless party. I did a lot of talking. Today I'm going to talk about zero-knowledge services. Password managers are zero-knowledge services where the user's data has a high degree of confidentiality. Only the user should know the credentials to get access to their data. But these products have been predominantly based on passwords, so we're going to look at how they may go passwordless. My name's Rue Islam. I work for a company called Dashlane, and for the last couple of years, I have been focusing on all things passwordless, helping Dashlane become a passkey manager, as well as turn the product into a passwordless product entirely. I am the co-chair of the FIDO credential provider special interest group, and I'm also the Dashlane board representative at FIDO. This slide is just to make me look important, but I just want to say that 2 years ago, I came to Authenticate and I didn't know anything, I didn't know anyone, but the people I met here are really incredible, and they helped me learn a lot about the technology that is behind FIDO. So if this is your first Authenticate, I highly recommend you to just turn up in front of people that you see and just ask them questions. You won't regret it. So 2 years ago, passkeys became a thing, and at Dashlane, we were really keen to manage passkeys just as we do passwords. And it felt like a natural evolution of the product to adopt passkeys. And today, almost all third-party password managers manage passkeys. But the experience of passkeys revealed a problem around password managers, which is how do you authenticate into the password manager itself? And that's what we're going to talk about today. So, just a bit of background. Password managers patch the password problem. They take what users do with password, which is really bad practices, and create high entropy passwords, always unique, always strong. And they synchronize them across devices. So that kind of sounds like synced passkeys, but the problem is these are obviously phishable credentials. So this is the origin of how password managers came along. The problem is that these unique and strong passwords need to be protected in some way. So the user needs to be able to log in to the product to access them. And how they do that is by using a password. So for three decades, these products have been using a password to protect passwords. The problem with this is, obviously, the password could be weak, and this product is promising to take away the password problem, but the first thing you actually have to do is set up a password. So a lot of these products deal with this by helping the user come up with a strong and unique product. So it always bothered me that, to use a password manager, you have to come up with a password, and it has to be strong and unique. So as I mentioned 2 years ago, passkeys became a thing, and these products also protect passkeys. And passkey private keys are managed pretty much the same way as the passwords that these products protect. The big difference is, and why password managers love passkeys, is with passwords, not only are they storing them, but they're also autofilling them. And the problem with that is these products need to understand what web pages are trying to do in order to autofill passwords. Passkeys are great because they're based on standards and like an API that is always deterministic. There's no guesswork in trying to guess what the web page is trying to do. This is why passkeys are great for password managers. But there's a problem. Like, we have phishing-resistant credentials that are protected with a phishable credential. And that's kind of awkward. And we're going to see if this can be fixed. So you might think, well, why not just use a passkey to protect your password manager? The problem with that is if you have to store that passkey somewhere. And if you need another password manager to access your password manager, it gets really confusing for the user. So we can see why this is a problem. If we look at this, this matrix of adoption and security. So passwords are clearly highly adoptable. Everyone uses them. But they're very low in security. And I put them on a spectrum here because you can have very weak passwords versus very strong passwords. But even the best passwords are phishable. And on the other end of the spectrum, you have device-bound, attested keys, which are super high security, but as we all know, not everyone has a YubiKey. So they're really hard to, it's really hard to get the adoption high enough for these credentials. And synced passkeys kind of sit in the middle. They're not as adoptable today as passwords, but that's going to happen in the future. And they're not quite as high security as device-bound keys. But the whole purpose of them is to get that high adoption. So if you protect your passkey manager with a device-bound passkey, then you're reducing the adoptability of synced passkeys. And where we really want to go is have higher security for synced passkeys and more adoptability. So password managers require a password to access the product, but passkeys also require user verification. So there are two aspects of password managers where passkeys are a bit awkward. First, you need to log into the product with a password, and you also need to do user verification, which sometimes requires a password. The current model, and the model that password managers have used for about 3 decades, requires the user to store the password in their head. And this password decrypts all the stored information in the password manager. And it's handy for the user to have the password in their head because they can go from one device to another and log in easily. But it's obviously a problem because it's a phishable credential. The model we want to go to, or where we can get rid of this password, is a model where the user doesn't have to keep a password in their head, but a low-entropy secret. And this low-entropy secret is not like the password because it's device-bound. This low-entropy secret will unlock a high-entropy secret on the device. So this is the model that we are heading towards. We're going from a model where the user has to think of a highly complex password to where they just have to remember a PIN, which is way easier. So it's a knowledge factor plus a possession factor because they need their device. And we use this pattern almost every day. So you have your phones, and you protect your phone with a simple secret. It's a knowledge factor, but it also requires the possession factor. So we think we're using biometry when we're using our devices, but actually it's always backed up by a low entropy PIN. But this model does create some problems for password managers, and we're going to look at some of these problems. There are 3 challenges with introducing a low entropy PIN to unlock a password manager. The first is, how do you provision a new device? How do you do account recovery? And the last one is a bit specific to third-party password managers. A lot of them use browser extensions. How do you use a browser extension? How do you sign into a browser extension with a PIN? That's quite challenging. So when the user is using a master password, they're storing the key in their brain, and they're going to a new device, typing their master password. So that's a knowledge factor. They typically do some MFA. So all of these factors are phishable, which is not great. And we can introduce a passwordless way of doing this by using some cryptography to transfer a high entropy key from one device to another. Typically, you will see this if you use WhatsApp or Signal and you scan a QR code. What you're essentially doing is taking the public key from the untrusted device and then doing some cryptographic magic in the background and bootstrapping that device. So there are passwordless ways of bootstrapping a new device. Account recovery is complicated. So in the world of master password-based password managers, if you forget your master password, it's game over. Like, typically, these products don't have account recovery. In the passwordless world, the equivalent of forgetting your master password is losing all your devices. If you lose all your devices, you no longer have access to the high entropy key because those devices are storing that high entropy key. So what can we do about that? Well, kind of the best solution and the easiest is just to get the user to store a recovery key. So you could argue that this is a knowledge factor. Typically, these recovery keys also involve some form of MFA. And the user's typically not typing this in every day, so the phishing part of it can be seen as more challenging, let's say. The other thing you can do is create a recovery contact. The problem with the recovery contact is that it's ecosystem-centric. So a Dashlane user needs to find another Dashlane user to protect their Dashlane account. iCloud keychain's the same. Google Password Manager's the same. So there are solutions, but I think that the problems are still to be solved around account recovery. Browser extensions. So password managers use browser extensions because they need to understand what's going on the web page, and it allows them to autofill passwords, addresses, etc. And we can also manage passkeys through browser extensions. However, using a PIN code to unlock browser extensions is very challenging. And what we found is you can easily implement PIN codes on native apps and mobile apps, but you're left with a password on the browser extension. So if you do user verification on a password manager, typically you're entering a password to use your passkey, which is very awkward. And what we found was that, well, ideally, we need a system on the browser extension where the user can come up with a low entropy secret, and the system can provide a high entropy secret as an output. And that's challenging on a browser extension because you don't have the same sort of APIs and the security model that a native app has. So what we found was that we could use some new cryptographic techniques or protocols. This one's called the opaque, augmented opaque protocol. What this allows us to do is the user can have a low entropy secret, a PIN code, and we combine that with some server functionality. The server will never learn about the low entropy secret, but the client requires the server in order to generate the high entropy key. The benefit of having a server involved is that we can also do an attempt count limit. that's the challenge with a browser extension. You need to be able to add an attempt limit, especially if you're using a low entropy pin. So this works, but it involves the server. So just to recap, the low entropy secret to unlock password manager is a viable solution, and that's what I think most password managers will head towards. Master password is a lot easier for the user, but it's just a lot more complex to implement. And I think the big challenge that we need to solve as an industry is how do we do recovery? Because if you cannot recover your password manager account, then you lose access to your passkeys. I'll just leave you with one data point. Since we've implemented Passwordless, what we've found is that authenticating with a PIN code into the password manager is highly effective because it's less of a challenge for the user to remember that low entropy secret. With a password, because it's highly complex and long, typically, users often fail to enter it correctly. So this is one of the benefits that we get from going passwordless. And that's the end of my talk. Thank you very much. Do we have any questions?
Who has questions for Rue? We can come up to the mic, or I'm happy to bring one to you if you're... Come on, don't all clamor. You only get access to the superstar one time a year. Come on.
I have. Hey, Rue.
Go ahead, thank you.
So thanks for your talk, very insightful. When you were talking about the contact recovery option, kind of you hinted at a solution that could rely on some like ecosystem-wide solution, like agreement or spec or something. Would you like to elaborate more on that? Are you thinking something similar to what is already being done with the credential exchange protocol, but for account recovery, something like that?
I don't have a solution, but I think the industry needs to come up with a solution because everyone's doing the same thing, and it's all... the way I look at it is everyone's inventing the seatbelt, where we should have a seatbelt that we don't need to invent. Everyone should be able to recover their account, and it shouldn't be like a competitive advantage to be able to recover. Like, this should just be a standard. And I think maybe that's the next frontier for FIDO to go and solve, because these products are storing a lot of sensitive information, increasingly sensitive information, and losing access to the account is incredibly painful. I think, yeah, there could be cross-platform solutions. I don't know exactly how that could work, but I think we have the right people in this organization to figure it out. And I strongly believe that it needs to be solved as the next challenge around passwordless.
Does anyone else have any questions for Rue? I have a question, because I always have a question. So when it comes to like leveraging credential managers, I think we look a lot at the UX aspects of this and like the learning curve for users, like consumer users. So like a lot of people leverage password manager. I mean, some people leverage password managers, but then so you've got kind of a curve of like with passkeys, like helping folks understand like you need to like kind of choose a credential manager and also like leverage that across your stuff. Because what we find in our research is like people don't necessarily think of browser. They think of that as like autofill, not as a password manager. So they think of that separately. Then they think of like what we sometimes call a third party. And folks that have third parties are like more understanding, where like folks that just kind of save in the browser don't really understand it that way. This is like, I'm going to get there at some point in time, I promise. But so it strikes me that, if we're, trying to help folks to get over the curve of one, like enrolling with passkeys, two, like trying to, get them to understand the credential manager aspect of it. And then three, like now introducing a new way to get into the credential managers. When we talk about like creating like specifications or like a new standard for this, like, shouldn't we be looking at like the UX like part and parcel with that, and like how like the solution would actually like you work to be like a good UX? Like how do we like look at that so that we're not like creating more friction in getting people into the credential manager? I mean, sometimes friction is necessary, but like we haven't even gotten everybody in there yet. So how do you think about that part of it?
Well, I think there's a lot of friction right now because of the fact that users need to think of and use a master password that's, you know, highly complex and easy to forget. Plus, it's phishable. So passwordless generally will lead to a better user experience, I think, just as we've seen with passkeys. I think it's difficult to rely on a passkey to access your password manager, but I think there are ways such as low entropy secrets to access the password manager. And honestly, like the data we've seen is that when we introduced passwordless, it wasn't a challenge for our users. They were used to accessing products in that way. So I think, yeah, the UX is going to improve if these products go passwordless. Absolutely.
I like to hear. Any other questions for Rue? And by the way, okay, good, great, I love it.
So your presentation title includes zero knowledge base. So in the almost last slide, you mentioned some protocol. You mean that is based on zero knowledge protocol, or?
The protocol itself is not, yes, there's an element of zero knowledge, which is the server component of that will never learn any significant information about the authentication flow. They won't learn the low entropy secret, and the server will not know the high entropy key. But the beauty of the system is that the client depends on the server to generate the high entropy key, and that low entropy secret only stays on the client.
Okay. So
It's helpful on the extension because we need a way to have rate limit, attempt limit, and it's difficult to do that in a browser extension because of the lack of APIs.
Any white paper, something is published?
It's, I believe there is an RFC for it, if I'm not mistaken.
Oh, okay.
Yeah.
Okay, thank you.
Yeah, it's called Opaque Protocol. Yeah.
Okay, thank you.
Hi, I just have a question about kind of in the password manager side of things. Has there been any thought on, you know, shared accounts? So one of the things we use Password Manager for today is we store that in so that anyone has access to a shared account, including the MFA code, because we can't tie that to a single device because 7 or 8 technicians can log on to that account at any time. In a passkey situation where we have that stored inside of a passkey vault or a password manager that has passkey capabilities, how are we revoking that type of access control or rotating that key or making sure that it's not stagnant on the system?
Okay, I think I understood the question, and maybe I'll repeat it because I don't think I quite heard. How do you deal with shared passkeys, essentially?
Essentially, yeah.
That's a great question. Sharing is typically done by value. If I share a password, I'm handing over the value of the password to the person I'm sharing it to. Similarly, a lot of products are sharing by value with passkeys. They're actually handing over the private key to the other person. What we want to focus on, or the direction we're heading, is sharing by reference, where the passkey private key is never actually given away. And it's not really the topic of the talk, but we think we can achieve this by hosting the private key in a secure cloud enclave. This way, you can give access to someone, because the beauty of the way passkeys work, you don't need to own the private key to sign a challenge. As long as you have access to the private key, which is somewhere, and you can authenticate to that private key, then that works. So we think sharing passkeys in a sort of enterprise environment could be done better than sharing by value, by sharing by reference in this manner.
Okay, thank you.
Any other questions?
We're from Microsoft. So I had a question about the device pin versus the password stats that you showed. Do you recommend people use different device pins across like the various devices they have this on, or like also is that data sort of inclusive of that?
No, we don't advise our users to set up a unique pin. I think the fact that you're coupling this low entropy knowledge factor with a possession factor allows you to set any PIN you want. That PIN is of no use to a remote attacker. Like, you have to have that physical device for that PIN to be of any value.
Yeah, I want to add to that question a little bit. So, for example, right, Android devices, not with Face ID, but the Android devices, you have like thumbprints. Maybe a family may have their kids or wives or husbands' thumbprints on it. And if you don't force an app PIN, the device PIN might be something acknowledged like what everybody has it. So how do you differentiate that access with a password manager? How do you make sure it is secure and given to the right individual?
Sorry, I didn't quite hear, but if I understand correctly, was the question, how do you have shared access to?
No, absolutely not. I'm basically saying like how you prevent the shared access. How do you prevent the shared access? For example, right, when you have a family of, let's say 3, husband, wife, and a kid, right? People play games, the kids play games on the phone. And they may have the thumbprint because for convenience we do that. And the PIN, whatever, you don't have a different app PIN other than the device PIN, you know, the kid may be able to access that because they have the thumbprint, which is a which is a biometric authentication for your passkey to release the private key. And then the knowledge factor is probably shared because it's on the device PIN.
Right.
So don't you think like an app PIN should be unique from the device PIN?
Yeah, maybe. I think the use cases that we're typically handling are not a situation where multiple people have access to that device and that password manager account. So I see what you're saying. Like, I think, yes, it is important to think about scenarios where multiple people are accessing that device, and they may have access to that password manager. But yeah, we think it's okay. Like, the model works for our user base, but it's not perfect, but it works well enough, yeah.
All right, well, please join me in thanking Rue. Rue, you're always the most wealth of knowledge. Thank you.